Hello, it's Virtual Mitchell again. Today we're going to get started with section 4.3, and this section actually reviews some things that you learned last year in pre-calc, but it's going to lead us to some things about integrals and kind of show us the purpose behind integrals in the near future. So to start off, just to kind of review, a sequence is something you talked about last year. It's a function with a domain of all positive integers. And sometimes 0 is included. So we don't put any decimals, fractions, negative numbers into these functions. We're just looking at integers that go in here. You may remember it when you look at a formula. An example would be a sub n equals 3n plus 2. That would be an example of a sequence. So the number of terms, or the order in which the terms go, is important. Kind of by the name sequence, the order matters. So a sub 1, if we put 1 in here, we would end up getting 5. A sub 2, our second term, if we put 2 in there, we'd get 8. A sub 3 is 11. So we can see a pattern if we write these out. We have 5, 8, 11, next one will be 14, and so on. You can see that these numbers are going up by 3 each time. This is an example of an arithmetic sequence because it has a common difference. A series is basically the sum of a sequence. So when we take the terms of a sequence and add them up, so we can look at the first 4 terms here. If we wanted to find the sum of 5 plus 8 plus 11 plus 14, that would be the sum of the first 4 terms. Summation notation, which is also more commonly called sigma notation, uses the Greek letter sigma. So an example of this, we would have the sum from k equals 1 to n of a sub k. Well, a sub k is just kind of our general formula for a sequence, kind of like this one, a sub n. So this would mean we're taking the sum of the first term, second term, third term, all the way up to the nth term, whatever number term this is. So the example that we had up here could be written in sigma notation like this. We go from k equals 1 to 4, because we did 4 terms, of 3k plus 2. That means we put the first term in, put 1 in for k, we get 5. Second term is 8, 11, and 14. So if we add those up, our sum would come out to be 38.